So you can simplify it before you get started. I wouldn't, because I'm lazy and I don't like simplifying twice. But you could simplify it before you get started and you will not get the wrong answer. You can multiply this by 2 root 8 over 2 root 8. That will not give you the wrong answer. It will make you have to simplify more at the end. So I would not do that. But again, it would not give you the wrong answer. It would give you the right answer at the end. I would multiply by just root 8 over root 8. Again, both of these methods are going to give you the right answer, but there's less simplifying to do if you do it this way.
Yeah, but why can you just change it to
Because it's 2 over 2, so you're multiplying by 1 either way. You're just multiplying by a 1 that's different. Because root 8 over root 8, that's 1. 2 root 8 over 2 root 8 is 1. So either way, you're taking this and you're multiplying it by 1. Now, if you put a 2 in front of it, your 1 is a little bit more complicated, which means your final answer is a little bit more complicated, and you're going to have to simplify it a little bit more at the end. You could actually put 20 root 8 over 20 root 8 if you wanted to. You just wouldn't want to because it would overcomplicate the problem. So there's a lot of different ways you could do it. We just have to have the root 8 in there. And the reason we want the root 8 but we're not worried about the 2 is because the radical is the problem. A 2 in the denominator is not a problem. A radical is. So that's why I'm not worried about the 2. I am worried about the radical. So I'm going to multiply by root 8 over root 8, but if you multiplied with the 2, you'll be fine. You don't have to scribble out your work. You'll get the same final answer that we get. It'll just be slightly different work than we have. So if I multiply the top by root 8, what do I get for the first term? I get, wait, what do I get? 4. If I multiply them together, I get 4. What happens when I multiply these two together? Root 8 times 4. I get 4 root 8. Root 8 times 4 is 4 root 8. You can't multiply the two numbers, yeah. One's not underneath a radical, one is underneath a radical. And then root 2 times root 8 is root 16. Okay? On the bottom, we have a 2 times root 8 times root 8, which is just 8. It's root 64, which is just 8. So on the bottom, we just have 2 times 8. 16. Okay. So we have root 16, which is, what square root of 16? 4. And then we have 16 on the bottom. And we have an 8 underneath the radical, which can be fixed. That's 4 times 2. 4 is 2 times 2. And so what do we have? We have a pair of 2's and a leftover 2, so that's 2 root 2. So if the root 8 is a 2 root 2, then what do we have? But you're not adding, you're multiplying. 8 root 2. Okay, so we have 8 root 2 minus 4 over 16. Okay. So we can't touch the radical, but we can look at all these numbers and we can divide all those numbers by the same thing. Divide them all by 4, and what do we get?
4.
Divide by 4 and we get 2. Divide by 4 and we get 1. Divide by 4 and we get 4. Okay, so the final answer is 2 root 2 minus 1 over 4. And it's going to equal the exact same decimal as the original problem, because all we did is we made it more proper instead of letting it be sloppy looking or slang. This is like slang math. This is your nickname. This is your formal government name. That's the difference. So if we type these in, we should get the exact same decimal. So 4 minus square root 2 over 2 square root 8. There's the decimal that it represents. And then if we type this in, 2 root 2 minus 1 over 4, same decimal. Same number, we just multiplied it by 1, so we changed what it looked like. We didn't change the number that it actually equals. Okay. So now don't feel like you have to write this down. If I had the problem root 5 minus 6 root 7 over 8 root 12, what would I need to multiply this by to fix the problem? What would I need to multiply this by to fix the problem? Root 12. Root 12 over root 12. That's what you would multiply it by to fix the problem. If you multiplied it by 8 root 12 over 8 root 12, you would still get the right answer. It would just be a little bit harder to simplify. At the end, you'd have to cancel a little bit more. You could also multiply it by 2 root 12 over 2 root 12. It would give you the same final answer. It would just be a little bit harder to simplify. You could also get real crazy and do negative root 12 over negative root 12 if you really loved negatives. You'd still get the same final answer. You would just be messing with negatives the whole time. Okay. All right. We're going to move on to another type of division. It's slightly more complicated. It makes the problems a little bit messier, but it's not the most terrible thing. It's very similar to what we were doing before. So these are when the denominators still have a radical, but they also have a plus sign. So here is an example. If we had 4 on the top and 4 plus root 2 on the bottom. So it still has a radical on the bottom, but it also has a plus sign. It makes the problems a little bit more complicated when you're doing something like this and you're trying to rationalize the denominator, which if you guys remember, it means to get rid of the square root in the denominator. So to rationalize a denominator that looks like this, you're going to multiply by something called the conjugate. So we're going to multiply, and the conjugate is 4 minus root 2 over 4 minus root 2. So right here, this right here is called the conjugate. And the conjugate is not just for what we're learning today. This is not the only time you're going to hear that term. The conjugate is anything like this where it's kind of like the opposite of something else, like the opposite sign, with the purpose of like canceling that thing out when you multiply it. The conjugate is a main idea. It's kind of like a math trick that helps when you do what we're about to do, and you'll see how it works. The conjugate is a really nice little trick. So conjugate is a nice word. I wouldn't necessarily in math too, if we were actually doing this as a class with like tests and things like that, I wouldn't test you on the term conjugate. But later on, it's something where like if you got into like a honors like pre-calc class or something, you'd be like, yeah, use the conjugate. It'd be like something that would like stick into your head as like, yeah, that's a great tool to use in situations where you get stuck. The conjugate is like a really nice thing to remember. So if we multiply on the top of the fraction, one term multiplied by two terms, how do we multiply these together? One term times two terms. How do we multiply them?
I thought they would just cancel each
What type of multiplication is this called?
other.
Distribute. Yeah, we're going to distribute. So 4 times 4 is 16. And then 4 times negative root 2 is, yeah, negative, and we'd say negative 4 root 2. Okay. And then on the bottom, if we have two terms multiplied by two terms, the correct way to multiply those out is to FOIL them, so that we have to multiply every single piece by all the other pieces. So I'll put these in parentheses to make sure that I am multiplying everything correctly. So I'm going to do 4 multiplied by 4, and I get 16. 4 multiplied by negative root 2, and I get negative 4 root 2. Positive root 2 multiplied by 4, so positive 4 root 2. And then positive root 2 multiplied by negative root 2. Negative, and not 4, but you're close. Root 2 times root 2 would be root 4. And root 4 is just 2. Yeah, you were right. It was just 2. So square root of 4 is just 2. Okay. So we can see that the two middle terms do what with each other? They cancel out. And with the conjugate, because you're always going to have opposite signs, that's how the conjugate works. You purposefully make the signs opposite. The middle terms are always going to cancel out. You're always going to have a plus version, a minus version of the same thing that cancel. And then over here, these were the opposite sign, but of the same number, which is intentional. That's how the conjugate works. We did that on purpose. Root 2 times root 2 was root 4. Square root of 4 is just 2. That was intentional, just 2. 16 minus 2 is 14. So on the top, we have 16 minus 4 root 2. On the bottom, we have 14. So we used the conjugate to intentionally get things to cancel out, get the radical to cancel out, get a whole number here. That's what the conjugate did. We intentionally did all of that. It was more complicated than what we learned last week, but it still achieved the purpose that we wanted, which was to get the bottom to not have a radical. Now we're going to ignore the radical here, but we're going to look at the 16, the 4, and the 14, and we're going to decide if we can divide the same number out of all three of those. Yes, what number? Not 4, because of the 14. 2. We can divide 2 out of all of those. So 16 divided by 2. 8, 4 divided by 2, and 14 divided by 2. So our answer is 8 minus 2 root 2 over 7. Okay. If we have 2 over 6 minus root 5, can somebody tell me what the conjugate would be? Take the bottom. It would be 6 plus root 5. 6 plus root 5. Okay? So let's multiply the top. What do we get when we multiply the top? 2 times 6 is 12. 2 times root 5 is 2 root 5. Okay. And then when we multiply the bottom, we have to FOIL out the bottom. So on the bottom, we're going to get 6 times 6, 36. 6 times root 5, 6 root 5. Negative root 5 times 6. Negative root 5 times 6. Negative 6 root 5, okay. And then negative root 5 times positive root 5. Negative root 25, which is just 5. Okay? What happens to the middle terms? Cancel out, they're gone. Okay? And so what do we have on the bottom? 36 minus 5 is 31. If we look at the 12, the 12, the 2, the 31, we're ignoring the radical. The 12, the 2, the 31, is there a number that could divide out of all of those? No. We leave it. That's it. Are these fun yet? You don't think these are fun? You guys. I think they're relaxing. I could just you give me a whole paper of these, I'll just sit there and
Do you do these before bed?
No, I don't. But if you gave me a sheet, if I was teaching this class for the first time or when I would just take home all the sheets that needed answer keys and I would sit there and do them before bed. Just make a bunch of answer keys. But I have answer keys now, so I don't need to do that. But if I did need to do that, it wouldn't bother me. It'd be relaxing. Yeah. 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 All right. Let's do this one, and then I'll let you guys try a couple on the sheet. So we have root 3 on the top, 1 minus 4 root 2 on the bottom. Anybody have a guess about what the conjugate would be? Yeah, 1 plus 4 root 2. 1 plus 4 root 2. Sorry, I'm running out of paper, so I'm gonna fold this over. Okay. So for the top, what do we get? Okay, 4 root 6. What'd you say for the first part? I agree with the 4 root 6. I don't agree with the 1. 1 root 3 or just root 3. Okay. Okay. All right, and then for the bottom, we got to FOIL it out. 1 times 1 is 1. Okay. 1 times 4 root 2 is 4 root 2. Negative 4 root 2 times 1. Okay. Negative 4 root 2 times positive 4 root 2. Negative 16 root 4. Negative 16 times 2. What's negative 16 times 2? 32. Okay, so this is negative 32. Okay, what happens to the middle terms? They're gone. Positive 1, negative 32, negative 31. Okay. Root 3 plus 4 root 6. Now, most math people would not leave the negative on the bottom of a fraction. Most people move it to the top. So if I take this negative and move it to the top, how do I correctly move it to the top if the top has two terms? You have to take the negative and you have to apply it to those two terms that are on the top. So I would leave the 31 on the bottom, and then I would take that negative and I would just make sure that that negative goes to the root 3 and that negative also goes to the 4 root 6. It's not a required step. You're not wrong if you don't do that. Like, you could leave the answer without doing that. But if you were to be taking like the SAT or the ACT or some sort of multiple choice test, it is very unlikely that you would see a problem with the negative left on the bottom. In most cases, they would take the negative and move it to the top because most math people do that. Does that make sense? Okay. So this is not wrong. If you guys were taking a test for me or another math teacher and you left the negative on the bottom, like, I personally would count that correct. I'd give you full credit for a negative on the bottom. But if it were multiple choice, I would put the negative on the top for my multiple choice answers. Okay. If it was the EOC, the negative would probably be on the top. Yeah. I think they should accept both. Yeah, they should accept both. Like for an AP type math test, they would accept both for sure. Yeah. Okay. But for the AP type math test, for a multiple choice answer, they would definitely put this one. I have learned that. Yeah. Okay. All right, go ahead on your worksheet and you're going to try number 15, number 16. 15 and 16 are like the examples we just did, so that's what you're going to try. Yes. Yes. Okay. So let's try an example before we try the worksheet. So here's how these ones are going to look a little bit different. Let's say that we had 3 plus root 7 over 2 plus 2 root 7. So if you can see, this is just going to be a little bit more tricky because the top, instead of having one thing on the top, it now has 2 on the top. So let's figure out what the conjugate is. Again, we only look at the bottom for the conjugate. So can anyone tell what the conjugate would be? 2 minus 2 root 7. Okay. Yep, just makes it so you have to FOIL the top and FOIL the bottom. That's just what makes these ones a little bit more annoying. So 3 times 2, 6. And because your conjugate is the conjugate of the bottom only, it's not the conjugate of the top, you're not necessarily going to have things canceling on the top. The top may not be as nice looking as the bottom does. Okay. 3 times negative 2 root 7. Three times negative 2 root 7 would be negative 6 root 7. So the numbers that are regular got multiplied, and then the root didn't get multiplied by anything. Then we have the root 7 times the 2 is 2 root 7. Okay. And then we have the root 7 times the negative 2 root 7. Negative 2 root 49. Okay. All right, on the bottom, 2 times 2 is 4, okay? 2 times negative 2 root 7 Negative 4 root 7. Okay. 2 root 7 times 2. Positive 4 root 7. Okay, those are going to cancel out. And then the last 2 root 7 times negative 2 root 7. Negative 4 root 49. So the 2's multiplied are 4. The root 7's multiplied together are root 49. Okay. So on the bottom, the middles cancel out. This is negative 4 multiplied by 7. Negative 4 multiplied by 7 is negative 28. Okay. This is negative 2 multiplied by 7. Negative 2 multiplied by 7 is negative 14. Okay. So we've got 6 minus 14. 6 minus 14 is negative 8. Okay. We've got negative 6 root 7 and positive 2 root 7. Negative 4 root 7. Okay. And then on the bottom, we have 4 and negative 28. Negative 24. Okay. So we're going to ignore the root 7. Then we have an 8, a negative 4, a negative 24. What can all of those divide by? 4. More than just 4, though. Not 8. What kind of 4? A negative 4. They can all divide by a negative 4. So negative 8 divided by negative 4, positive 2. Negative 4 divided by negative 4. I'm going to write plus 1, positive 1. Negative 24 divided by negative 4, positive 6. So this is going to be 2 plus, you can write 1 root 7, or you can just write root 7, divided by 6. Ugh. Okay. So let's do number 17. We'll start number 17. We'll see how far we get. And then number 18 will be homework. So what's the conjugate for 17? 6 plus root 3. Okay. So then if we multiply the top, what do we get? So 2 root 3 times 6 is 12 root 3. And then 2 root 3 times root 3. 2, so plus 2 times the square root of 9. Okay. Negative 3 times 6. Negative 18. Negative 3 times root 3. Negative 3 root 3. Okay. And then on the bottom, we have 6 times 6. 36. 6 times root 3. 6 root 3, okay. Negative root 3 times 6. Negative 6 root 3. Okay. Negative root 3 times positive root 3. Negative root 9. Okay. So negative root 9 is... That's negative 3. Okay. What's 2 times root 9? 2 times 3, which is 6. Okay, this is just 6. Okay. What happens to these two? Okay. So what do we have on the bottom? 33. We have 6 minus 18 on the top. 6 minus 18 on the top. Negative 12. 12 root 3s minus 3 root 3s. 9. We have 9 root 3s. And then what can all of these divide by? They can all divide by 3. So finish 17 and then do 18. And then you guys are going to finally turn this sheet in tomorrow.